Okay, so these are the words, you guys, part of your assignment today and part of like our things we do is just making class. One talker. I can't continue if you're talking. Okay, so radius is always just that one from the center to the edge. What is a diameter? What's a diameter?
Like double the radius.
Yeah, diameter is double the radius. And it's always a chord, and it goes through the center. So a chord is just any segment inside the circle. Okay? So it can be the radius, it can be this, but it has to be endpoints on the circle. Is the radius a type of chord?
Yes.
Well, so chord has to have endpoints on the circle. So is a radius a type of chord?
No, because it only goes to the middle.
Yeah, because it only goes to the middle. But diameter is a chord. Okay, can you guys say secant? Secant. Okay, so down here, secant is the one where it's like a chord. It has two endpoints on the circle, but it continues. It's a line that continues. And so when we're labeling things, the only difference between a secant and a chord sometimes is just, is it labeled with the segment sign or the line sign. And then tangent. Today's lesson is about tangent. So tangent is a line outside the circle. So it's the outside line. And it touches the circle exactly one point. So it's just coming along and brushing up against the circle at one point. Okay, so in the next one, we're just labeling. Okay, who can tell me? I'll take a volunteer. What is a radius here? AB. And so if you remember, when we label these AB, and it has a line over it because it's a segment. All right, what could another radius be?
AD.
Yeah, or AD. And is there a third one?
AF.
AF. So even though AD and AF are part of the diameter, they're still radius if we choose to look at just that part. All right, would someone from my square group tell me what is a chord in this? You guys are squares, right? So what is a chord? DE, yes. So DE, as long as we label it with the chord symbol and let know, okay, I'm just looking right here, this part, not the part that goes outside the line. All right, would someone from our trapezoid group tell me what is the diameter of this? So DF is our diameter, and again, I use my chord symbol. All right, someone from the parallelogram group, what's a secant? All right, so secant, remember, is anything, it's like a chord, it just continues on outside. So what line do we have here that cuts through the circle and continues?
Yes.
Yeah, it's that same DE, but we're going to label it differently because we're including the whole thing, including the line that goes out of the circle. So notice the difference. Segment DE is a chord, line DE is a secant. That's a D.
So if it's a line, put arrows. If it's a segment, you just put a line.
Yeah, so if you're doing secant going all the way out, that's the secant. All right, and someone from our oval group in the front, what is the tangent here? Yeah, so B is the point of tangency. And this line, they didn't actually label it with anything for me, so I'm just going to write line containing B. Well, we can't say line B because B is just one point. Lines, we have to have 2 points.
B is in the middle.
B is in the middle, so it's
Maybe they were saving
a point on it. So if they had given us a second point, we could have said line that way, but I'm just writing this because that's more exact.
Correct, Mish.
Thank you. All right, we have 2 rules here that we're going to use to solve everything today. The first one, can you read this and tell the person beside you what word or two do you think is most important in this sentence?
Wait, what?
So read this theorem 10.1 and tell the person beside you, what do you think that means? So important words here are both those you just told me. So tangent and perpendicular. Perpendicular to what? Radius. Why do we like the word perpendicular in geometry? Because it's long, because it's nice. What does perpendicular let us do when we are solving?
Jordan's creepy.
Do we know what a perpendicular angle measures? What's it measure?
180.
Perpendicular.
Measures 90 degrees, right? So we know if a line is tangent, we have a 90-degree angle here that we can use to solve for whatever they're asking us to solve for.
It's basically a right angle.
It's a right angle. Perpendicular means right angle. Okay, what is the most important word in Theorem 10.2?
Tangent.
Tangent. And what about tangent this time?
Congruent.
Congruent. So if we have two tangents, so we have a point out here and two lines going touching the circle, they equal each other. Is that also important when we're setting up the equations and solving it?
Yes.
Okay.
If it wasn't, it'd kind of wrong.
All right, so when you have flip. Okay, so it tells me find the segment length indicated. Assume that lines which appear to be tangent are tangent. So what are the two things we know when we say tangent?
They're tangent.
Yes, it's outside the circle, and that means tangent means they're perpendicular or they equal each other, depending on what they've given us. So do I know that one of these angles is 90 degrees?
Yes.
So if this is 90 degrees, can I use Pythagorean theorem to solve? Yeah, so when you see something set up like this, you know that's 90 degrees, you use Pythagorean theorem. Okay, so a squared plus b squared equals c squared. So did they give us a really easy, like a and b or a and c?
No.
No, so what do we need to do first?
Add 12 and 8.
Yeah, so first we add 12 and 8 to find out the whole thing's 20. If the radius here is 12, is the radius here 12?
Yes, because they're...
Yes. Radius is always the same. So first we had to do just that little bit of add those two to get the whole thing. Recognize radius equals each other, so that this is also 12.
C squared minus b squared.
So then I'm going to label this a, so like a squared plus 12 squared equals 20 squared. Does anyone want to try to mental math that?
18.
It's 18?
A is 18.
All right, so we have a is 18, so we got 400.
Oh, no, I was just
Oh, you're guessing? Oh. So 400 minus 144 when I square those, or you can type the whole thing in straight into your calculator.
I forgot how to divide.
So it's just, you can just enter 20 squared minus 12 squared is 256. Is 256 a perfect square?
Yes.
And if it isn't,
And so if it isn't, that's when we simplify the radicals down. But it is. So my answer is 16. So now I say, is 16 a logical length for that picture?
Yes.
So if this is 12, that's 16, the whole thing's 20. That's a logical length that fits with the other two sides. All right, so we're going to take about 2 minutes. See if in your group you can solve problem 2. All right, who remembers, what was our second rule we used for tangents? First one was perpendicular. Second is
Oh, it was right angles.
congruent. So all I have to do, these come from the same point. They're both tangents, so I just set them to equal each other. So 14x equals 15x minus 2.
it's just pretty simple. But like, what do you do in like when there's the number 4 though?
We'll get to that in just a minute.
Yes, ma'am.
Okay, so then, sorry, I did that wrong. I should subtract 15. So now I have negative x equals negative 2. What does positive x equal?
positive 2.
Yeah. So x equals 2. I'm finished.
That's it?
That's it.
That's easy, miss.
Did we need the 13.4?
Yes? Yeah?
No, it was just the radius, which is the
Oh! Miss, I'm missing. Other part.
We are recording, yes? Okay.
That was Oliver Witz?
No. Okay.
That was Oliver Whitaker in third period. I'm just kidding.
Okay, so we're going to pause again, just for like 1 minute, see how quickly you can set up and solve question 4. Okay, so the last one, it says determine if line AB is tangent. So this is going to be our answer will either be tangent or not tangent. What did they set up for us here? Is that the equal, two external ones equal?
Perpendicular.
It's the perpendicular. So if it is tangent, then a squared plus b squared will equal c squared. Okay? If it's not tangent, then it won't. Okay, so if it's tangent, we need this to happen. So here's my a, here's my b, here's my c. So we do 5.6 squared plus 9 squared equals 10.6 squared.
And then if the calculator says false, it's not tangent.
And then if the calculator says false, it's not tangent, or you can do each side together individually. So I'm going to do 5.6 squared plus 9 squared, and I get 112.36,
So it is not tangent.
or 10.6 squared. I got the same thing.
Really? Can I see the...
Oh, yeah.
Yeah. After we've done problem 6, yes. Yeah, so true means it's yes, it's tangent. So if I enter them separately, it does that. I will in a minute. I'm showing people what I entered.
Yeah.
Or if you enter it with the equal sign, these calculators will do that. So the answer is tangent. Okay, without talking to the people beside you, see if you can set them up and give me a thumbs up if you say it's tangent, thumbs down if it is not
I will
tangent.
do.
So plug it into your calculator. Tell me what you think. So problem 6. Thumbs up if it is tangent, thumbs down if it's not tangent. Make sure you have your work to back up your answer. Did you get your work? So what is 13 squared equal? Oh, we do have to do some. You guys, is 6 the whole thing, or 6 just half
No,
of
you
it?
have to subtract. The answer.
So 6 is right here. So what's my whole side going to be?
3.6.
12. Yeah. So
Oh, 'cause it
yeah.
has to
So my numbers are 9, 12, and 13.
169.
All right.
There you go.
Miss. 13 squared is 169.
So 13 squared is 169. So how about 12 squared plus 9 squared?
225.
Yeah. So that comes out to 225. And so it's not tangent.
Hey, miss, you saw me do the... If you just type
Yeah. So that's the other thing you can do is just do 13 squared. Where's my equals, what was it, 12 squared? And it tells you true or false for you. Okay, so we're now going to do the big ideas assignment, and then we will do today's quick check the last few minutes of class.